Hello, back again. Going to start doing some of the wiring. So thought I'd just take a closer look at navigating this Arduino Mega board, called Mega because that's what it is. 2568, so that's some kind of version or release number. I think this is V2 or V3 version 3. There it is it? Come on. Somewhere it says that. Anyway, the working bits we're going to use are these, sorry about the focusing, these control terminals here. You can see this strip here starts with the common 5 volts there and common ground there. This is focusing, is diabolical. That looks like about the right numbered 22 to 52, and even though it's cut off there, the other side of that 22 is 23. So I'm going to use, I've got 6 switches, so I'm going to use control terminals 22 through to, was it 32? 26, yeah, so that's about 6. And the LEDs will use the control terminals 23 through to 37. I think I've got my maths wrong there, but sorry, to 33, not 37. The other parts of this board we use are, see that there, the TX1 is to send Midi signals. It might be this TX0, sorry, to send Midi signals. If you can see that. This is annoying me if it's not annoying you that you can't see the TX0, sorry. There it is there. And the reset terminal there. Oh, this, okay, finally got some focus. So, USB 2 there, power in, 9 volts go in there. So that's about all I'm going to use. That's a reset button there. So that's all I'm going to use on this Arduino Mega. I mean, I could have used a much smaller board like a Uno or other kind of Arduino boards, but this is one I salvaged from another project, so and I'm very familiar with it, and all my other sketches to run these things are written for Mega, so unless size and space is a problem, go with what you know. And the difference between a Uno board and a Mega board, I don't know, $5-10 or something, so that's not the issue. And there's plenty of space here to do this sort of thing. So the first step is, and you can see that's, again, that's where that USB from that panel. So this is a panel mount USB connector. That's how you program the, connect to your computer to program the Arduino unit. So that's going to be there. This is going to be here. So that we'll just plug into there. As usual, they're always the wrong way around, but there's plenty of leeway in the wire, plenty of lead in the wire to get there. So that's the way it's going to work. So I don't have many skills in terms of YouTube production, but the first step is to clean up these old wires from here, and to start looking at the wiring for connecting the control terminals and the switches. So if you remember my last video, I said what that means is the control terminals all work on negative, on earth. So these switches will have a common earth, which will be connected to the control terminal for the common earth here, and the control terminals are activated by looking for the switch to go to earth. So when these are all momentary switches, it's very hard to use latching switches with this kind of setup. You can, but it's just painful. It assumes you're going to use momentary switches. You create the momentary switch circuit, and the board recognises that that control terminal is now gone to earth and activates the program based on that. With the LEDs, it will use a common positive. You really need to provide a separate power supply for the positive, because these boards don't have a lot of output, and if you start driving things like LCDs and LEDs, you run out of power quickly. I think I'm going to try and use the Arduino to drive the LEDs in this case, because I'm not using a lot of power. LEDs, I think they use 10 or 40 milliamps, I don't remember, but there should be enough power coming out of this board to drive 4 LEDs, because that's all I'm using the power from the board for. If I was doing an LCD display or running a lot of LEDs or other things, I wouldn't bother. But it means I don't have to do extra wiring if that's the case. So that's what I'm going to try and do first, and if it doesn't work, I'll have to take the positive power supply directly from the power supply itself and see where we go from there. So here we go. Let me just make sure we can all see this. So just cleaning up the terminals now. And I've seen other people do this on YouTube, so I'll probably, well, not probably, I am going to try and speed this bit up. Handiest tool ever, for soldering at least. Come on, get in there. Just tighten these up a little. It's just annoying them. I just feel them loosely. It's annoying the way they're just spinning around like that. Just make sure we're still in focus there, are we? Yeah, we can still see everything. focus in shot. Annoying like that. Right. The thing with soldering is that you only get heat transfer if the solder's wet. So the real trick, I don't know if you call it, the thing you got to be careful of, not so bad with fairly largish components like this, is that the longer you want quick heat transfer so you can melt the solder but not melt everything attached to the component the solder's attached to. So actually having a soldering iron too cold, you're more likely to cause a problem than a much hotter soldering iron. I recently got soldering a soldering unit, induction soldering unit for my birthday or Christmas, and I've got it set at 415 degrees, but this probably I'll go up to, I'm just setting it up to 430. I'll just wait for it to reach that temperature. Usually it takes, see, there we go, we're at 430. And just see, get the soldering iron wet. For some reason, sometimes they're just stubborn. Like that, there we go. And I used the solder sucker to get the excessive amounts of solder off some of those. So this one's got an excessive amount of solder. Not just solder, but reuse them. So one of the things with reusing these switches, that resoldering them probably takes more out of the life of the switch than actual usage. So that part of it's done. The next part is to work out how we're going to wire these. So I'm going to start by getting a pencil and marking them up. So this is going to be going back to, this is going to be 22, 23, 24, 25, 26, 27, 28, 29. I'll mark it here because I won't be able to see that when I put the board onto the onto this section here. 30, 31. Oh, there is no LED there, silly me. 30. But I'll keep the numbering conventions going and I'll make this one 32. Alright. Common earth. Which means firstly, I have to get from the ground to one of these terminals. So let's go back to what I'm salvaging here. See if I can get one of these DuPont connectors that I've already used to do the same job. There should be legions of them here. So this one should do it, and it's green for earth, so I'll use that one. wet again. Yeah, it's hanging on like grim death. There we go. So the first thing I'm going to do is create my common ground. So this is a DuPont connector. This has got the square type. So just looking at that, so I'm sure there's lots of people who know a hell of a lot more than me about this stuff, but if you're interested, there's two types that have a sort of a rounded casing here, but a DuPont connector is exactly what you see. One of the advantages of this one is you can see it's got, if I can get this in focus, hang on, let me get this here. You can see it's got that metal strip exposed in the casing, which means when it's plugged in, you can actually attach to that for testing, which can be quite handy just to do continuity tests or whatever. So it's got a bigger package in terms of its casing, so it stands up more proud of the surface, greater height, but it's got that advantage of being able to test it whilst it's plugged in, which can be very handy sometimes. So, DuPont connector. I know a lot of that was out of focus, but I think you get the idea. So, just little things can make life easier. I'm going to route that. I'll just put that under here because I've got the wire to do it. And I'm just going to take that over to here, and need a bit more solder on that. Okay, so we now have an earth. Next I'm going to need some wire to do the common earthing, and I'll get some This is the wire I'm going to use to create the common earth. This is a relatively thin gauge wire because there's no real power going through these, so it's much easier to use a thinner gauge wire than something heavier. It makes no difference, just easy to work with. And this is, I've got a whole roll of this stuff. My ex-brother-in-law, my wife's sister's ex-husband, gave me a huge roll of this, so I'll use that to create the common earth. So, introduce another tool for those who don't know, a wire stripper. Makes life so much easier. Works great on lower gauge wires. On heavy gauge wires, not so good. So I'm just going to create a wire for common earths amongst these. So I usually just try and measure it out. So first thing, just to get that right, we're going to do from there to there. So cut, strip. There we go. Which means this end will do the same. Cut. Strip. Connect. 1, 2. 1, 2, 3. I need another one, which we'll do here. Cut. Strip. Connect. Good enough yet? 1, 2, 3. 2 more. 1 more and then the end. Cut. Strip. Right. Now, so you can see I'm bringing out one tool after the other here, but see, that's in focus. Right. I'm now just going to solder these, so best not to do that over the circuit board there. So we'll just push that up there. We'll do that there. That's a magnifying glass there. Alright. Tin it. That's all I need there. So, in case you're interested, this is the solder I use. I don't know one solder from another. I use this, it works. 7.7 mil, 60% tin, 40% lead. And I've still got my temperature up at 430. I'm going to take that down to 400 now. It's just a little too hot for what I'm doing here. I'm 400 degrees on my soldering iron. Before I had this fancy unit, I had one control on my soldering iron that was on and off. So I'm still learning about temperature control for soldering, but see, I'm going to take that back up to 415 because that was a little slow there. If I was soldering a component of some sort, I probably would have melted its insulator. Okay. Let's go. Let's just check we're still in focus there. Just. Very good. So this solder has a flux core, which means flux is like, I guess, the chemical equivalent of a catalyst. It just allows the transfer between the surfaces. I don't know exactly how it works. It's usually some kind of diabolically toxic acid like sulfuric acid and other things. Good shot. Got on my tool. There you go, that's why I didn't do it over the circuit board. So I've got every solder joint done. Alright, now put the third arm away. Get this back into focus here. Now create the common earths. We start here. Need more solder. All right. Yeah, now I have to put the temperature back.